going in that direction of the car.
So I thought there was air on both sides. It's a motor too, yeah, that's what I was wondering. Well, so the motor making the car move, or the fan?
The air from the fan.
The motor makes the fan.
So, yeah, the motor just makes the fan move. But
Oh,
the
yeah,
air is making the car move. You said, okay, yeah, different thing. Okay.
The blade in the fan is actually providing lift, and you have drag, which is similar to the reason why a plane actually flies. It's called maneuvering, where as the fan is turning, the lift instead of going up, is pushing out, and that's transferred as a whole machine.
So, right on. I guide you toward the answer, but I don't know anything about the airplanes.
I'm sorry?
You said something about air. You said something about airplanes.
Yeah, the blade of the fan is providing lift, but same way that the wing on the plane does. So
Instead of in providing that the car won't go up, you know, instead of
it won't go up, but because of the direction, the orientation of the blade
right.
is causing the air to flow this way. But still, the reason why it works is because on one side of the blade, air is traveling faster than on the other side. So that causes your pressure.
But yeah, the blade, it is pushing it that way, but the force is what I'm thinking of acting on the car. The amount of force that's on the car is actually pushing it so that in the direction where the car is traveling. Because
Net force. Essentially, you're saying net force.
net force.
Well, because, right, the net force is in the direction of the force.
So from like Newton's second law, which our kids know, like we know it, acceleration is happening in that direction, so net force has to be in the same direction of the direction. So then what's making it go in, what's the force that makes it go in that direction?
Force.
The
Air.
airplane is but it didn't ask net force, it just asked.
Yeah, sorry. I was just.
No, I was just thinking that's why like I would have made this arrow longer. So
So the total, like I said, you know, when it's not moving, there are the air is in every direction, but there is no actual force because it's zero. Everything is zero, it cancels out. So when you increase, you know, the amount of air by turning on the fan, then you know,
when the fan moves the air, that's when the thing moves.
the air is actually pushing.
Thank you. So, quick question.
Yeah.
So pre-assessment, did you, and we had the same conversation, did you want these questions to be like your pre-assessment questions, or like this is what we're doing to get started with
This is what we're
class?
going to get started.
Okay,
Basically, my whole lesson is centered around the bottom.
okay,
But,
uh-huh.
Just
This
to get
was
an
like your
idea
do now
that
kind of
air
thing?
can push things type of thing.
Uh-huh.
To know that air can push things. So, should I?
No, I was just curious because, like, I guess our goal kind of with the pre-assessment is for it to be given, you know, days, weeks, whatever in advance of your lesson so that you have some data. So I was just curious if this was what you wanted to do that, or if this was, if you meant to kind of say like pre-class kind of questions. So, no, it's not an issue. I was just.
Because I was trying to engineer it so that it can be any class.
Yeah.
They can answer in their own words, what they think.
And we have
So then she's just saying with the technicality of the wording, it's not a pre-assessment then, it's your do now or your catalyst. That's all she's saying.
I'm a pre-assessment. Okay, I'm sorry.
no. Sorry. Yes. Thank you for clarifying.
No, it's not pre-assessment.
Okay.
So there was a fan, like right here, a big fan, if the car moved in the opposite direction, move this way, but when the fan is gone, the car moves that way. So if the fan, there was a bigger fan, would it move this way?
Wait, so if I had a bigger fan here and it's blowing that way,
Right in front of it, would the car move this way?
if it can like, yeah, if it's a bigger fan and it like just applies a bigger force, then it's not gonna move.
Oh, but I'm saying if that was on top of it, if that was still like it was before, and there was another fan.
If there was another one, so it's going this way, there's another fan here, like what would happen?
Sorry, that was really loud.
I thought it was the other way around before, wasn't it?
Mhm.
Okay, yes, I mean, like, it was the same way you
So
had
this
it.
one, and then
So if it's this direction, so it would be moving, so it would be moving that direction, and you're putting a fan here facing that way.
Then it would move this way.
No, then it'll move that way.
Oh, I thought it's facing that way, it would move this way. It doesn't. Oh.
So if you have this set up right now, and you turn this on, it's gonna go that way. So now you're saying there's another fan here. So they're both gonna make it go that way.
Oh.
And so since you're combining the forces, right, they're going the same direction, you would add them together, so then that force is larger and there's more acceleration.
I thought that maybe this area was like using this for like push off. That's not what's happening.
So the way that I use this in my classroom is we say the fan is spinning, right, and it's pushing the air, and it pushes the air in this direction. So why does the fan go that way? Because the air pushes back. It's actually,
why does the car go that way?
yeah.
It would be just like if you were pushing yourself off of the wall on this chair. That's the same.
Yeah, so you push the wall, but the wall pushes back on you, so you go that direction.
Okay, just to clarify what you said, with the concept of equal forces, well, with every force, there's an opposite force. It might not necessarily be equal, because when it's not equal, that's when you have movement.
Within a, yeah.
Just in this scenario, what we're talking about. Like, I just want to clarify what you said, when you turn the fan on, the fan blades make the air go this way, and you said the reason it goes this way is because that's air pushing back.
I'm sorry, you go ahead, because I can't explain the same thing.
So that's the question. As you go higher altitude, the air is thinner. I thought that was all right.
Well, why do we feel air pressure? Like right now, why do we feel the air pressure? Where's it coming from?
Why do I feel air pressure now?
Well, you might not, I mean, we don't really feel it, but it's here, right? It's pushing down on us. Where does that come from?
Oh, it's from the air pushing, it's the gravity.
So we're thinking about all the air molecules straight up, right? If I have a square inch, all the air molecules all the way up, right?
Mass of the air.
It's all, yeah, the mass of the air. So if you go higher up, is there more mass of air or less mass of air?
That's,
Yeah, so if there's less air pushing down, then there's less air pressure.
so if you get to a point where the fan, even though it's turning, it will not have any effect.
Oh, that's a good question.
So
Yeah.
if it's turning too much.
No, as you go up,
Mm-hmm.
the air becomes thinner.
Mm-hmm.
So the effect, the net effect that it will have as far as it being able to drive.
I would think that it would be less effective, right? We would
So
see
you
less
get to a certain
acceleration.
point where the density is too low,